Welcome to the Z-Hut's Mad Scientist Laboratory. I'm Professor Z, and today we're going to attempt to take over the world using Arduinos. Grab your favorite Arduino board and put on your tinfoil hat, because it's time to build.
Today, we will be attempting to take over the world by building this Bluetooth-controlled power outlet. Now, this outlet is not designed to be put in your wall. This is made to work with an extension cord or to be plugged into your wall. I only have about a 3-foot cord on this right now. For doing the tutorial, I will be adding, I've got a 20-foot cord I will be adding to this, and I will be using this for turning stuff on and off outside. Quick disclaimer before we get into building it. Build and use this at your own risk. This is not a project for beginners, by no means. This is something for somebody that knows about electricity and electronics. If you don't, I at least have somebody there to help you build this that does. So with that, if you decide to go ahead and build and use one of these, the Z-Hut is not liable for any loss of life, property, injuries. If you cause the total destruction of the planet, well, it's all your fault. Do not try to hold us liable. This video is for entertainment and educational purposes only. Please don't try this at home. All right, I have to say that. All right, so what we'll do first is I'll give a quick demonstration of this working. And we've got a lot of info to go through, so I'm going to try to go through this pretty quick to try to keep the video as short as possible. But we will demonstrate it working first, then we will look at the construction of the enclosure, then we'll look at the circuit, and we'll look at the Arduino code real quick, and we'll also look at the sketch real quick, or excuse me, the app real quick. Now, you can just download the app. You don't have to make your own, but I will also show you how you can go and make your own app to control this. 100% free. It's MIT App Inventor 2, and you don't have to know any programming. This is drag and drop block programming. You don't have to code. So all right, well like I said, I want to try to run through this as quick as possible. I've got this little night light, and I just taped over the photo resistor there so it will come on, being my video lights are shining on it. We'll open up the app. It's right there. Hopefully you can see this. It has a big connect button there. Push that, we select. Now make sure you already paired your Bluetooth module with your Android device before you try to connect, or it won't. Now we're connected. I just made this simple. One button. When we get over to the app, I'll show you can add 2 buttons and on and off. This one, you just hit it once, it turns it on. You hit the same button again, it turns it off. I just made this very simple. So you can go ahead and modify this. But like I said, we got a lot of stuff to go over, so I'm going to move through this a little quickly. This app can be found on the website. Look in the description below. You'll find a link there to download it. Sorry, it's not on Google Play. I am not putting any viruses on or anything, so don't worry. I made this app myself. This isn't by anybody else. So to disconnect, you just hit the back button and it automatically disconnects. All right. Turn it off. Side. And as you can see, when I disconnected, because the relay was still on, it didn't shut the relay off in here. It keeps the power on. So you do not have to have the app running for this to work. So, all right, I'm going to pull that out. Disconnect the power. Like I said, I was using kind of a short cord. This is just an old computer power cord. All right, the construction for the body. We have a 3-inch test cap. This is one of the ones that fits over the top on the outside. We've got 6 inches roughly of 3-inch PVC pipe. We have a knockout test cap. Nice. Get it out of there. That's one of these. Now, I haven't glued anything yet, but this will be getting glued in there. Now, we're using the knockout in the bottom because otherwise this flange wouldn't fit over it. This fits on the inside of the pipe, and this keeps all our electronics from, one, falling out, two, keep moisture, dirt, and stuff out, because when I am done with this, I am going to be painting this, and I am going to be caulking everything. I'm going to be making this so it can be used outside. All right, then of course we've got this flange thing. I'm sorry, I don't know the exact name of it. What it is this goes on the floor in your bathroom. It actually sits this way, bolts to the floor, and you put your wax ring on there and you bolt your toilet to this. If you go into your hardware store or home improvement store and just describe to them what that is, it's for the toilet, they'll be able to point you to where these are. You want one that fits 3-inch pipe. All right, now we're also going to need, of course, electrical socket to plug in. You're going to need a faceplate. You're going to want the cheap plastic ones. Don't get any of the specialty ones. Don't get the stainless steel or metal. It just won't work as good. All right, so I'm going to describe how we make this fit first, and then I'll go into how we get the plug in there. But these covers, when you get them, they're flat. What I did is I put it in very, very, very hot water. It wasn't boiling. You don't want to melt and deform the thing. Then I put it on the pipe, and I put some straps around it, these little pull straps I have. I'm sorry, I forgot to bring one in. You could also use zip ties or something. Put it on there and conform it to the 3-inch pipe, and then let it sit and cool down for a while. Then when you take it off, it's going to bow back a little bit, not much. It'll conform to it good enough that then you can go ahead and drill your holes in it for your screws. And I just used my rotary tool and I drilled them out. I drilled on the faceplate so that the screw fit through. And then I used a different size bit on the inside so that the screws would actually screw into the plastic and hold. There's no nuts on the back side. These are just screws. All right, the rest of the construction. And I haven't glued the base on. I probably won't glue this particular part on. I'll leave it so I can pull it off if need be. But if you want even more stability, you can put a piece of plywood under this. But I do believe this will be stable enough, at least for what I'm doing. All right, I'm going to go ahead and set that off to the side. And, all right. Oh, also the cover, the top, sometimes they'll fit snug, sometimes they'll be a little loose. I still just went ahead and I drilled the same way I did this, did a hole in the front, hole in the back, and I put 2 screws in to hold the cover. So I'm going to go ahead and pull all these screws out, and I'm going to speed the video up to warp speed because, like I said, we got a lot of stuff to go over here. All right, I got all the screws taken out, and as you can see, here's the cover plate I'm going to show you. It is kind of holding the shape. Not perfectly. When you put it on there, there's a little gap on the side, not much, and that's why we went ahead and did the screws. And if you're going to be using this outside like me, we're going to want to weatherproof it. I'm going to have to silicone, do a lot of work, but I'm not going to cover that in this video, so let's just move on. Now for cutting this out and putting our plug in, what I did is I put my end cap on. Then I took and put my plate on, and then I traced out the 2 holes that the socket goes, because I wanted the plate to pretty much touch the top of this and have as much of my 6 inches left below to go into the base. Then I just took and measured just a little bit each way, give a little extra room, but still have enough to where the cover is going to completely cover all the gaps. And then we're also, so we still have enough room to screw the plug in. And as you can see, and I do have more pictures on the website. Once again, you can find a link to that in the description below. All right, on the inside, we have our relay is on the side. And don't worry, on the web page again, I'm going to have, this is glued in. I'm going to show you as best as I can, but on the web page, there's some pictures, and actually, some point here in just a moment, I'll pop one of those up on there so you can see what this looks like being pulled out. But I have my relay here, and I just used a little bit of hot glue on the top to stick it to the side to keep it in place. And this is a 10 amp relay, so make sure you do not want to pull more than 10 amps through this, or you're going to start a fire. It could cause problems. Well, it'll at least at minimum destroy the relay. I do recommend putting some kind of circuit breaker or fuse on this. I only had some 15s, so I've currently ordered some, I think they were 8s, because I want it to be well protected. I don't want to run it at the max. So I do recommend some kind of circuit breaker with this. All right, so we got the relay there. Right here is my HC06 Bluetooth module. I'm going to go ahead and pull that out of the way so you can see. And there's my Arduino board, my logic level converter. And as you can see, I soldered together on a point-to-point solder board. There really is not enough room in here to put a solderless breadboard. And I do not recommend one for this project. You are going to actually want to solder the board together. If you're not good at soldering, hopefully you can find somebody to help you with that, but I do not recommend putting a solderless breadboard in there. I would recommend the point-to-point soldered. And I used headers on everything so I can replace parts if need be. Or if I'm not going to be using this for a while and I need an HC06 for, temporarily for another project, I can just remove it. But the Arduino, the HC06, and the logic level converter are all on headers, so they can just plug and unplug. There, it's back in there. And once again, that is also hot glue gunned. I'm going to open up the back side here. And what we're powering our Arduino with is just a old phone charger. Now, I found most of the older ones run at about 7 volts. So that way, I took and wired it. I took the plugs off, took it apart, put my own wires to the AC input, which is hooked up. And you'll see on that picture too. Matter of fact, here's the picture of it right now. Put it up in the corner here. But I just took and wired my own wires, and the AC side goes to the AC, and I ran it before the relay because we don't want it to turn the power off, when you hit the relay or something. So make sure you hook it up by following the schematic, which is on the website. But as long as it's 7 volts or more, you can run it to the V-in on the Arduino board. Now, if you get it really regulated, you're going to want to test these. You're not going to just want to take it and plug it in and assume. You're going to want to take your voltmeter and test it. If it is 5 to 5.5 volts, you want to run it to the 5 volt pin on the Arduino, not the V-in. If it is greater than 5.5 volts, you want to run it to the voltage in, not the 5 volt. There's 2 pins, a V-in and a 5 volt. 5 volt is 5 to 5.5. If you run 5.6 to this, you're kind of pushing it. I really would try to even stay away from 5.5. I try, if it's not 5 to 5.2 volts, I won't even use it. But all right, you can find links to where to get these on the website as well. All right, I think we've gone over everything on this. We're up to about 10 minutes so far, so I'm going to try to keep this video under 20 minutes. It is going to take us a few minutes to go through the rest of this. So, all right, any questions you got on anything, just leave a comment. So I'll worry about putting this back together later. Let's get over to the computer. Let's take a look at the Arduino Sketch first. That'll be pretty quick. We should be able to make it through that within about 5 minutes. And then we'll take a look at the code for the app and MIT App Inventor. And if we still got some time, I'll go over the schematic real quick. Otherwise, if this is starting to get long, I'm assuming you know how to read a schematic. And I made the schematic up myself, and I have everything labeled pretty clearly. And it should make sense to you. So, all right, let's get to the computer and take a look at the Arduino Sketch. All right, for a copy of this code, once again, just go to the website. You'll find a link to that in the description below. So, all right, there's not a lot on this you're going to want to change. If unless you are completely redesigning this thing. So I just have my relay is on pin 2, digital pin 2. I have an integer here, and we're calling it state, and that's just keeping track of if the relay is on or off. Then we got our serial.begin in 9600, which is very common. In our pin mode for the relay, of course, it's an output. In the void loop, now we are receiving a 2-byte number from our app, so don't change any of this right here at all, or it will not work. And trust me, sending the 2-byte numbers from the app and receiving them doing this, it just works a lot smoother. And I always do it this way, even if I'm sending a real tiny number. It makes things work better. All right, so we've got an if statement, so it's checking val, the number that's coming in, and I just have it 1, 2, 3, 4 is what the app is sending. And if that's what it receives, and the state is 0, which means the relay is off, we're just digitally writing the relay high, turning it on. And then we have an else if, and make sure you have an else if. If it's just an if, what'll happen is it'll turn it on, turn it off, and it'll be so quick the relay won't even activate. So we have to use an else if. We're checking if the val equals 1, 2, 3, 4, and the state is 1, which we set it here. Once we turned it on, we changed that to 1. It is digitally writing the relay low, and then setting the state at 0. Now, I am using just the one button. You could get rid of the state, the and the state statement here, and just have if the val equals 1, 2, 3, 4, turns the relay on, and then in the app, if you had a second button, you just have it send a different number. Let's just say 5, 6, 7, 8 it would send, and then you wouldn't need the state comment here as well. And you could turn the relay off by doing it that way with 2 buttons. I just simplified it for this tutorial with 1 button. All right, and that's it. So let's get over to the MIT App Inventor, and I'll run through that real quick. All right, I have MIT App Inventor 2 opened up here. If you've never heard of this before or haven't used it, just do a Google or favorite search engine search for MIT App Inventor 2, and it should be the first search result that pops up. I'll try to remember to put a link in the description below for MIT App Inventor as well. But all right, let's just get right into it. If you haven't used it before, you could probably skip this step until I have some beginner's lessons. Check my channel out. I got some beginner's lessons on how to use this, but let's just get right into it here. I'm going to go through it, and I'm just going to expect you already know at least something about MIT App Inventor. So, all right, I just got my 2 labels up here with the name. I got my channel name and what this is called. Then I have a list picker here, and I put a picture on there to make it look like a button, and it just says connect. And then I have that other button. It's hidden at the moment, so I'm going to display show hidden items, and I'm going to click scroll so we can scroll down. So then I have a connect button, but it is not visible at the moment. The only reason we're seeing it is because I'm displaying hidden components in viewer. So how this is working is it's basically we're doing virtual screens. Instead of having the connect button on all the time, it just, once you have connected, the connect button disappears and the power button shows up. So let's get over to the blocks and just take a look at it here. So all right, we've got our list picker, our before and after picking. And if you've done this before, I'm sure you know how this works. We're just connecting to our Bluetooth we're going to our list of Bluetooth devices and we're selecting which one we want to connect to. Then after you've picked it, we're connecting to what you selected. And then right here is what we use to make the buttons disappear and the other appear. If the Bluetooth is connected, then it sets the connect list picker to false, makes it disappear, and sets the on-off button to visible, true. Then if we click the button, it sends the 1, 2, 3, 4, and like I said back in the Arduino Sketch there, you could do a second button and have it send, say, 5, 6, 7, 8, and have one button for on and one button for off. But for this tutorial, we just have one button. Then I have it set up here. If a screen error occurs, say you have the app open and you walk out of range, or for some reason the Bluetooth gets disconnected, when you hit that power button again, instead of getting an error message on your screen, it'll just automatically set the connect button back to true and then set the on-off button back to false so it doesn't show up and it has the connect button showing again. So then you can just go ahead and reconnect. And to disconnect and close the app out, I just did it all together. When you press the back button to close the application out, it just disconnects your Bluetooth and closes the application. And once again, if the relay is on when you close it, the relay will stay on. If the relay is off when you close the app, the relay will stay off. Now on the website, I will have a picture of the block diagram here. I'm sorry I won't have a picture of this. But all right, I think that's about it. This video is starting to get up there, so I'll just bring the schematic up super quick here if I can, if it'll let me. All right, bring this in here and try to make it fit in the window. Here's the schematic, and you can get this on the website, and go ahead and feel free to print it out. As you see, I have everything labeled very clearly. One thing, the relay you use, make sure you use one that has the optocoupler in it, that it keeps it separate. It optically connects it instead of physically, electronically connects it. That way when the relay is closing, you're not getting a voltage spike back in your Arduino in your circuit. And also in case something shorts out, fries on the AC side, it's not putting 110 volts AC to your Arduino. If you're not too sure what that is, just do a search. When you're looking for your relays on eBay or Amazon, just put in relay and then put in optocoupler and they'll pop up. It's just this little module. On the website, you'll find links to them. We have our logic level converter because I believe in those instead of voltage divider networks. I prefer those because our HC06 is 3.3 volt logic, but the Arduino we're using is 5 volt. And just remember, the HC06 needs to be powered by 5 volts, but the logic levels need to be 3.3 volts. And everything else is labeled clearly. The white wire, the black wire, and the ground wire for your AC is clearly marked here. And here's our phone charger. So, all right, I'm going to go ahead and wrap this up. Hope you found this information useful. You did, please give us a thumbs up. Appreciate it big time. With that, I hope you have a great day. And remember, and this is very, 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 very important, remember to always, always wear your tinfoil hat when you are building. We do not want the government and the men in black to know what we're up to.